Ibrahim, is it audible?
Yes, ma'am, you're audible.
Okay, we were discussing the Coulomb's law. So one question only we discussed. One more question I'm writing. Okay, please start writing this.
Yes, ma'am.
Look, Ibrahim, this question says two conducting spheres of equal radius have charges plus 10 millicoulomb and minus 20 millicoulomb respectively. And they are placed at distance capital R from each other when they experience force F1. So this is like, this is 10 millicoulomb. This is the second one. And this is having minus 20 millicoulomb. And this is having experiencing the force F1. So you tell me, what will be the Coulomb's law?
Ma'am, F is equal to K Q1 Q2 by R square.
Yes. So K into, tell me for the situation.
What, ma'am?
No, how we'll put it in the formula?
K into 10 into 20 divided by R square.
This way.
Yes, ma'am. Is that right?
Millicoulomb also, no?
Oh, yeah. Into 10 power minus 3. Into 10 power minus 3. So that's 10
Now,
power minus.
see, this is a question of ratio. If you see, you have to calculate the ratio. So in this case, I'm just putting this as millicoulomb only because it will eventually get cancelled. So this is 10 millicoulomb into 20 millicoulomb. Okay. Now, see, it is saying this is what is our Coulombic force. Second part says here, if you read, it's saying if they are brought in contact and then they are separated, okay, to the same direction, they experience force 2. If they are brought in contact and they are getting separated, so which property is this? They are
If
coming
they're
in
bought,
contact, and which one?
if they're bought in yes, ma'am. Because they're bought in contact and separated to the
Yes,
same
look at
direction.
this line. If they are brought in contact and they are separated to the same direction. Experience the force.
Yes, ma'am.
Yes, what is this property?
Ma'am, there's like charge, unlike charges, so they should attract. Is that right?
No, no, no. If the charges are brought in contact and they get separated, so are the charges getting transferred or not?
Yes, ma'am. Yes, ma'am. The charges will get transferred.
So
Yes.
any method you can recall from this?
Yes, ma'am. It is transfer of charge. Yeah, I think I wrote it somewhere.
See, have you heard of this? Charging.
Yes, ma'am. Charging by conduction. Yes, charging by conduction.
Yes, charging by conduction. So
Yes, ma'am.
we did remember we discussed in the last
Yes,
class.
ma'am. First class we discussed. Yeah.
Yeah, we have discussed that what are the methods of charging. So this one, that when the bodies are identical, so how are the charges transferred? So Q1, Q2 by 2. So right now also the same thing happened. If they are brought in contact and then they are separated, but the distance is same. So see, this is the body minus 5 millicoulomb. This is separated to this body which is minus 5 millicoulomb, right? Because both of, how will we get minus 5 millicoulomb? See, one charge was 10 millicoulomb, other charge was minus 20 millicoulomb, right? Earlier it was 10 millicoulomb minus 10. So when you add 10 minus 20 by 2, what do you get? Minus 20 by 2, that
Yes,
is
ma'am.
minus 5 millicoulomb.
Minus
So
1
now you are
millicoulomb.
getting
Yes.
minus 5 millicoulomb and they are separated. So now you tell me what will be F2 here?
So, ma'am, F2 will be K 5 into 5 into 10
Yes.
power minus 6.
Yes, 5 millicoulomb into 5 millicoulomb. See, right now it is given all of the charges are in millicoulomb. So we can just put it as it is because it will get cancelled
Okay.
and divided by R square only. So
Yes,
look,
ma'am.
this was your first force. Now if we take the ratio, we have to get the ratio between F1 and F2. So F1 is K 10 millicoulomb into 20 millicoulomb divided by R square, and your F2, which we have just got it. This is the value of F2, which is K into 5 millicoulomb into 5 millicoulomb by R square. So R square gets cancelled. K gets cancelled. Now see
Yes,
here,
ma'am.
millicoulombs will also get cancelled. That's why the conversion didn't affect much. And this is 2 and this is 4. So ratio is 8 by 1. F1 by F2. Got it?
Yes, ma'am.
Okay, write this, then we'll see Coulomb's law in vector form.
Yes, ma'am. Done. Finished. Hold on. Yes, ma'am, done. Yes, ma'am. Yes, ma'am, done.
Okay, look, Ibrahim, now we have to look at the vector form of electrostatics. So it's similar to what we've already studied, vector form of electrostatics. So force is equal to K Q1 Q2. Now remember, this is we are writing in vector form. So this arrow will always come whenever you have to represent vector. Either you can put the vector like this, F with an arrow, or you will see this is present in bold. Okay. So this is force. So F is K, Q1, Q2. Now you divide it by R square and multiply it to its unit vector. Or if you have to write it with the sign, you can write this as K Q1 Q2 by R cube when you are writing the position vector as it is. See, there's a difference between when we write this. This is the unit vector of position. And what is this? This is the position vector as it is. So in both the cases, whether you're writing the unit vector or the position vector, this is written with the sign. Means then you don't have to write the magnitude. Okay, you don't have to write the magnitude. The way in Coulomb's law, we emphasize that we always write the product Q1 into Q2 product of the magnitude of the charges. So here in this case, when you're writing it in vector form, because you're already mentioning it as a vector quantity, right? So you need not mention any of it. Like I think I'll just show you a question. Okay, you didn't attempt it in one of the classes we discussed. Just a second. So that exact question came, and see, options look very confusing because when you are studying a topic, and if the magnitude has been taught and you are completely taught that you just have to write everything in terms of magnitude. So when you have to write, when you cannot write or ignore it. So remember, in this case, when you are writing the vector form as it is, okay, in the vector form as it is, you can avoid writing the rest of it values. Okay, so it depends on your value that you have chosen. Like I'll show you a question. Wait. Ha. Look at this question. This will give you a little bit idea of what we are studying. This was the second question. Yeah, this is the third question. Look, Ibrahim, read this. What do you think is the answer? An electron is moving round the nucleus of a hydrogen atom in circular orbit of radius r. Means this is the radius. Electron is moving around the nucleus. This is the nucleus of the hydrogen atom. This is how the electron is moving. Okay, radius is r. This is the radius. The Coulomb force F between the two is. Yes, Ibrahim, what do you think is the answer to this?
No more here. What's the second charge in here?
What?
No, there have to be like two charges, right?
Yeah, so nucleus is there, no?
Okay, so nucleus is positively charged. No, wait, no.
Yes, yes,
K
you're right.
K E square divided by R square R vector. I think it's C.
You think it's C option. That is K E square by R square into R cap. Okay, look, Ibrahim. Here
Mm-hmm.
we are talking about the charges on hydrogen and electron, right? We are talking
Yes,
about
ma'am.
their charges only, hydrogen and electron. So we know
Yes.
our formula is, let's say right now we don't know anything. Let's take one as Q1, one as Q2. So when you have it, see, C is actually not the right answer. I'll tell you, you're very close, but just a little incorrect. See, when we are writing something in the term of Coulomb's law, what are we going to write? If we have F is minus 1 by 4 pi epsilon naught Q1,
Mm-hmm.
Q2 divided by R square when we are talking in terms of unit vector. Correct. This is what you said. R square, R
Yes,
cap.
ma'am.
But right now I am going to put a negative sign. Why?
Mm-hmm.
Because one thing, see, what are these two particles which you were getting confused with? One is the electron. So one of this Q1, when we are referring, this Q1 is actually electron,
Yeah.
and electron is having the charge minus E. So
Yeah.
this is one charge. When we are coming to Q2, Q2 is the nucleus of hydrogen, and hydrogen atom has one proton, okay,
Mm-hmm.
as the
Yeah.
nucleus. So when one proton is there, it is plus E, correct?
Yes.
And what did we discuss before this? That here in vector forms, you have to include the signs also, right?
Yes,
You
ma'am.
have to include the sign also. Now look, let's just match all the options here. First option say this is not negative. So these two options are incorrect anyways, because when you multiply minus E into E, you will get minus E square. So answer will be having negative because all these are written in vector form. And this, when this
Mm-hmm.
is given you in bold, Coulombic force, F is given in bold, it has two meanings. No, means it has a single meaning, but it can be written in two ways. The F vector, when you are writing, this is how you write the F vector, or it can give you this in bold. This is also the vector only. So question is actually asking Coulombic force F with this symbol means the vector part is written. Okay, so between the two.
Yes, ma'am.
When it is vector means we have to consider these, and we have to include the signs also. So
Science.
these two
Okay.
options are incorrect. Now let us check between these. Unit vector, when you have unit vector, see this is the unit vector. When you have the
Mm-hmm.
unit vector, you have r square in the denominator. Look, like this was
Yeah.
correct. If minus sign was there, this would have been right. Right, minus
Mm.
k e square r cap. So r cap is there, then you have r square, but this is r cube. So this is incorrect. So you have the correct option as B. See, r vector divided by r cube. Look,
Mm-hmm.
r vector divided by r cube or r cap by r square. Is this concept clear, Ibrahim?
Okay, okay, yes, ma'am, yes, ma'am, yes, ma'am,
Okay.
yes, ma'am.
Write it. We'll see one more question based on this, but a numerical we'll see.
Mm-hmm. Let me just write this down.
Yes, yes, please write it.
Yes, ma'am, done. Yes, ma'am, done.
You write it, Ibrahim. Meanwhile, I'm writing the next question, okay?
Okay, ma'am.
Ibrahim, did you write the above part or should I scroll it above for you?
No, no, ma'am, I wrote.
You've written? Okay. Look, this question, this is now completely in vector form. This says that two charges, A means 100 microcoulomb, B minus 600 microcoulomb. They are present at points. This is the P point, this is the Q point. And we have to find out the force. So this is a normal question of Coulomb's law only. You have the charge A, you have the charge B, and the separation is R between the forces, the way we calculate. But right now the issue is that we do not have these data as it is. Okay, charges we can say, this we can say B is there, but this separation is not given as it is. So how do we calculate? So it means you need to find out the formula first. Formula says K, Q1, Q2, R vector divided by R square, because everything is given in vector, so no need to write unit vector. Use unit vector only when it is stated. Otherwise, start with this. You'll be in the safer side. Now, we have to calculate the separation. This is the magnitude. Remember one thing in the formula, Ibrahim, this is the vector.
Yes, ma'am.
And this is the magnitude of the vector. So RA, what is RA given? Tell me.
R at A, that's I cap plus J cap plus K cap.
Correct. Because A is at this point P. So
Yes,
this
ma'am.
is I cap plus J cap plus K cap. This is RA. And what about B? RB?
B is at Q. 2 I cap plus 3 J cap minus K cap.
2I cap plus 3J cap minus K cap. This much of
Yes, ma'am.
meters. Okay, right. So we have this information with us. So we need to get out the separation first. So how can we get the separation if we have 2 points? Anything that you can suggest?
Ma'am, R of B minus R of A.
What?
RB minus RA.
Yes, very good. We will calculate RBA first. That is RB.
Yeah, RBA
Yes,
minus
RB
RA.
minus R. So we have 2I cap minus I cap plus 3J cap minus J cap plus minus K cap minus K cap. So our position vector that we require, RBA, between them, because two different points were there. This is now I cap plus 2J cap minus 2K cap. Now, this we have got, but we need to get the magnitude also. So, Ibrahim, do you know how to calculate the magnitude of a vector?
Ma'am, we take, so that will be 1 plus 2 minus, that's 1 meter.
No, not 1 minus 2, something else.
No, wait,
See,
yeah, what?
should I tell or can you
Yes,
recall?
ma'am. No, if you'll tell, that's better.
Okay, see, take under root of, then take the squares of the coefficient. Now you'll recall 1 square plus j is, this is 2 square plus coefficient is minus 2. Take the coefficient square and add them. 1 square plus 2
Ah,
square plus 2.
yes, ma'am, yes, ma'am, yes, ma'am.
So this
So 1
is
plus 4 plus 4, that's a root of 4, 8, 9, that's
9.
3.
So that is 3, right? So we have got, this is given in meters. So this is 3 meters. Now
3
we are
meters,
ready to
yes,
put
ma'am.
everything in our formula. Yeah, one more thing. Charges are already given in the question, right? So, okay. I have to put it in the formula. Now, what is the formula? Because everything is in vector form, so we are also going to use it in vector form. Now, see, options are, I have not written the options of this question. Usually, we write the things depending on the option. But see, this is a full-fledged question from the vectors. That's why I just took this. So, this is K, Q1, Q2 into R vector divided by magnitude square. Now, you keep on telling me the values. What should I write for K?
9 into 10 power 9.
9 into 10 to the power 9.
9.
And what should I write for Q1?
100 into 10 power minus 6.
Okay, and for Q2?
600 into 10 power minus 6.
See, here is the mistake. Minus you
Oh
have
yeah,
to.
no, minus 600, minus
Yeah.
600.
Okay, see, remember, in NEET, this is because you are preparing here for NEET. In NEET, both the kinds of questions can come. So when you see
Mm-hmm.
vector form, then only tell yourself to take this negative. Otherwise, you
Mm-hmm.
take, when you have the normal formula, no, k q1 q2 by r square, take the magnitude only. Got it?
Okay, ma'am. Yes.
By the way, if you see previous year's papers, recently the questions have come from electric potential. The recent
Mm-hmm.
ones. Electric questions are there from the first chapter also, this chapter also, and these are important. And anything can come. All the papers are unpredictable. But from electrostatics, potential part was there much. So yes, you are right. 100 into 10 to the power minus 6 into minus 600 into 10 to the power minus 6. Now we have to put the r vector. What should I write?
Ma'am, R vector will be I cap plus 2 j cap minus 2 k cap.
Correct. The RAP. This is R for us now.
Yes,
So
ma'am.
this will be I cap plus 2 j cap minus 2 k cap. This divided by. Now magnitude we have calculated. We just
Yes,
have to
ma'am.
put the
9.
magnitude, that
T
is
squared
3
plus
square.
9.
So that will cancel off this 9 also.
Yes, ma'am. So 100
So
into minus 600
yeah,
into
so
10
6
raised to
is
the
there.
power minus 3.
3
100
got
into,
cancelled. So this is 6, right?
yeah. Yes, ma'am.
So what will it come?
100 into minus 600 into 10 power minus 3. Now we
Hmm.
can solve that.
Minus 6 will become minus 12. And 9 and
Uh, yes, ma'am. Yes. And 9 minus 12 is minus 3.
and see, you will be left with this term also, right? You will be left with this term also.
Mm-hmm.
So what
Yes,
will you
ma'am. Yes,
do
ma'am.
for this? You will put its magnitude ultimately. But your answer will be in this vector. If the question says answer it in vector form, then this value which you are getting. So
Mm-hmm.
this is already, yeah, we were calculating this. No? So this is 10 to the power 2. This is 10 to the power 2. So 4, 9 plus 4, 13. And 13 minus 12, right? Minus 6 minus 6. 13 minus 12. That
Yes,
is
ma'am.
10.
1.
1.
10.
Yeah.
Yeah.
So you get 60 here minus 60 into I cap plus 2 j cap minus 2 k cap. This is the answer in terms of vector. But if you have to answer it in terms of the magnitude, if the option says,
Mm-hmm.
then you calculate this magnitude, that is 3. So in 3 multiplied, that will be minus 180. But in
Yes, ma'am.
magnitude, we won't write the minus then. If you are going to write it, this will be then, this is 60 and this part will be 3. So this will be 180 Newton. If it comes to write in terms of magnitude. So you check the option, whatever option is mentioned. This is in terms of magnitude and this is in terms of vector.
Vector.
Got it?
Okay.
Okay,
Yes, ma'am.
Ibrahim, write this one also.
Yes, ma'am. Yes, ma'am, done. Yes, ma'am, done.
Okay, Ibrahim. Now see, Coulomb's law part is done, but in Coulomb's law, we just have one thing, that is the whenever the charges are present in a different medium. So electrostatic force between charges kept in a medium. So when you have the medium, so one thing you tell me, what is dielectric constant equal to? Ratio of. If I have force in air and force in a medium.
Ma'am, F of ma'am, force of medium with respect to the air. So Fm divided by F0.
Fm divided by F means, can I write it like this? F medium by FO, or you just tell me, I'm giving you two things. FO by F medium, which one of them is correct?
Ma'am, Fm by Fo mostly.
FM by FO, first
Fo.
one. This?
Yeah,
Yeah. See,
I
when
think
you
so,
have the
mostly.
forces in the medium, your force in air will always be divided by K. Okay, whatever is the dielectric constant, right? So your force in the medium will always be, you have the force in air, it gets divided by K. Now tell me, which is right? Yes, Ibrahim, now which
Yes,
is
ma'am.
correct?
F K is equal to F0 by O. Okay.
Yes.
Second
So
one.
whenever you have the force in the medium, remember that it gets divided by the dielectric constant. So this one isn't correct. That's why I wrote both of them, because these are very confusing while writing. And remember, values of K, you need not write. You already know the values of K. But remember, for water and air, two materials, just remember them. One is air. Air the value of K is 1, and for water, the value of K is 81. These two remember, that's it. Okay. All right, Ibrahim, just quickly write it and then I'll continue it in the next class.
Okay, ma'am. Okay.